We're going to be demoing the washer method, which happens when you rotate a graph around and create a solid. So we're going to start out by drawing our two functions. The first function is y equals x squared. And then the second function is going to be y equals 2. And we're basically going to be looking at the area where they intersect and create a shaded region, which is demonstrated in the video. And then we're going to be rotating this solid around the x-axis. Next, we need to find our radiuses that we're rotating. And to find the smaller radius, little r, we're going to take your pencil and draw up from the x-axis, and you'll eventually hit the function y equals x squared. And to find big R, we're going to draw all the way up to the end of the bounded region, which would be 2. So big R is 2, little r is x squared. And then to find the volume, you're going to be using that function, or that. Next we need bounds, which is where the two functions intersect, which is 0 and 1 in this case. And that would be the x values of 0 and 1. Then we're going to plug in little r and big R into the equation and square them, subtract them from each other, and include the dx and the pi.
Dude, Mitch.
Next, you're going to simplify it down to get that to a little bit more workable. So it's going to come out to 4 minus x to the 4th dx in your integral from 0 to 1.
Can't tell what's the next square again.
And then to evaluate this function, you're going to end up taking the antiderivative, which in this case is 4x minus 1/5 x to the 5th, evaluated at 1 and 0, times pi. So now that we have that, we can simplify that down and evaluate at our two values. We'll start with pi times 4 times 1 minus 1/5 times 1 to the 5th minus our other value, which turns out to be 0.
Yes.
Then we're going to plug in our answers and work it down, and you will come out with 20/5 minus 1/5 times pi. That'll eventually simplify down to 19 pi over 5. So the volume of that region would be 19 pi over 5 units cubed.
Yep, go.
Now we're going to find the volume of another solid using the same washer method. We're going to draw both of the functions onto the graph. First function is x equals 2y. And the second function is y squared equals x. Now we're going to shade in the region where they intersect. And it's going to be rotated about the y-axis in this problem. So it's a dy. First we're going to draw little r from the y-axis since it's a dy problem. And the first function that it hits is x equals 2y. And for big R, we're going to draw another line from the y-axis until it hits the second function, which is 2y. So big R is 2y and little r is y squared. And the points of intersection for this problem will be 0 and 2. So the bounds for the integral will also be 0 and 2. And we're going to set up our integral here. Substitute in big R, which is 2y, and little r, which is y squared.
Really?
Because I don't want to sing in front of people.
Yep. Actually.
Now we're going to make the integral a little easier to deal with.
Nice.
So it's going to end up being 4y squared minus y to the 4th dy.
Yeah, stockbroker. Stockbroker.
Now we go ahead and take the antiderivative of this integral. So we get 4/3 y to the third minus 1/5 y to the fifth from the bound 0 to 2. Now we can go ahead and plug in 2 and 0 for our y. So we get 4/3 2 to the third minus 1/5 2 to the fifth minus 0. Now we're going to simplify this down to get our answer. And we get pi times
Here we go.
32 over 3 minus 32 over 5.
I'm building.
And our final answer for the volume of the bounded region is 64 pi over 15.
We're going to be demoing the washer method, which happens when you rotate a graph around and create a solid. So we're going to start out by drawing our